Hi to everyone. This is Sindhuja, Department of Mathematics. So now we are going to discuss about the topic matrices and calculus. In that the first unit is matrix eigenvalue problem. So before going to the matrix eigenvalue problems, let us have an recap of what we studied in the previous classes. That is, what is matrix, eigenvalues and eigenvectors, and how it is applied in our day-to-day life. And as we know, we are in a design thinking based concepts. We are interconnecting that matrix, eigenvalues and eigenvectors with a DT based approach. Clear? So, let us have an introduction of a matrix. So, a matrix is a rectangular array of numbers, symbols or expressions arranged in rows and columns used to represent linear transformations, system of linear equations or data sets in various fields like mathematics, physics, computer science and engineering. Matrices are fundamental in linear algebra, enabling operations like addition, subtraction, multiplication and transformations such as rotations, scalings or projections. So, the size of matrix is represented in terms of n cross n, where n represents rows and n represents columns. So, now let us have a discussion about the application. By solving the system of linear equations, we get the solution for equations, which is in the form of Ax is equal to b, and representing transformations in computer graphics, data analysis in machine learning, network analysis, that is adjacency matrix. Apart from this, there are major fields where the matrix are used as an main concept like cryptography, coding, decodings, etc. Then let us have an touch on eigenvalues and eigenvectors. Eigenvalues and eigenvectors are concepts in linear algebra associated with the square matrix. An eigenvector of a matrix A is a non-zero vector V such that when A is applied to V, the result is scalar multiple of V. So, AB equal to lambda V, where lambda is an eigenvalue. They are critical in understanding the behavior of linear transformations. So, now this is the recap of matrix and eigenvalue and eigenvector. Let us have some topic of design thinking and how it is interconnected with our topic. So, design thinking, we know having 5 stages: empathize, define, ideate, prototype and test. So, we explore eigenvalues and eigenvectors conceptually and practically here. So, empathy is nothing else but understanding the user's need. So, objective, identify why eigenvalues and eigenvectors matters to users, that is students, engineers, data scientists. So, users may need to understand matrix transformations, that is in graphics, physics, so on. Solve problems in stability analysis, quantum mechanics or machine learning, that is PCA. So, students may find the abstract nature of given values challenging. Engineers need practical applications like vibrations analysis. Data scientists seeks eigenvectors for dimensionality reductions. So, all these comes under an empathy. So, here what we are trying to define here, that is clarifying the problem, is how can we make the concept of eigenvalues and eigenvectors intuitive, accessible and applicable to diverse fields. That is, what are eigenvalues and eigenvectors mathematically? Why do they matter in real world application? How can we compute them efficiently? Clear? So, a square matrix A with an eigenvector V not equal to 0 satisfies AB equal to lambda V, where lambda is an eigenvalue. Solve the characteristic equation determinant A minus lambda equal to 0, where I is the identity matrix. Or we can go for the formula lambda square minus S1 lambda plus lambda 2 equal S2 equal to 0 for 2 by 2 matrix, and for 3 by 3 matrix as lambda cube minus S1 lambda square plus S2 lambda plus S3 equal to 0. So, the roots of this polynomial are eigenvalues, and for each eigenvalue we get the corresponding eigenvector. So here what is ideate in the design thinking approach? That is brainstorming solution, that is develop creative ways to explain and apply eigenvalues and eigenvectors. So the geometric interpretation is eigenvector represent directions unchanged by transformations, that is only scaled by lambda. For example, in a rotation matrix, eigenvector might be the axis of rotation. Eigenvalues help analyze scaling or sharing transformations. So then what is meant by prototype? That is building solution. Find with the help of these concepts, eigenvalues and eigenvectors, we are finding a building a solution. So let us give an example with the 2 by 2 matrix 1, 1, 3, minus 1. So let us take it as an capital A and find the characteristic equation by the formula A minus lambda I equal to 0 or lambda square minus S1 lambda plus S2 equal to 0, which will be your step 1. So what is S1? That is nothing else but sum of main diagonal element. What is S2? Product. Clear? So S1 is 0 here and S2 is minus 4. Clear? S2 is nothing else but determinant T. Okay. So we get the characteristic equation as lambda square minus 4 equal to 0. Since it is a quadratic equation, we get the two roots. The roots are named as an eigenvalues, which is comes under step 2. So the step 2 is finding the eigenvalue. So as we know, lambda square minus 4 equal to 0 have the roots as minus 2 and 2, which is an eigenvalues. Step 3 is finding eigenvector with the help of formula A minus lambda into x is equal to 0. So when you are substituting the given matrix A and identity matrix I and x is an unknown vector x1, x2 and substituting the lambda as minus 2, we get the corresponding eigenvector capital X1, minus 1 and 3. When you are substituting the lambda value as 2, we get the eigenvector as 1, 1, which is an eigenvector. So likewise, we can find the solution for any 2 by 2 matrix to get the eigenvalues and eigenvectors for any kind of problems, which will be the evaluating and refining comes under the last stage of design thinking, which is test. Clear? As a conclusion, as a summarizing of what we have seen so far is, using design thinking framework, we have explored eigenvalues and eigenvectors by empathizing with the user needs, defining the problem, ideating creative explanation, prototyping calculations and visualization, and testing their effectiveness. Eigenvalues and eigenvectors are powerful tools for understanding matrix behavior with applications in physics, engineering, and data science. By combining mathematical rigor with intuitive visualization and practical examples, we make these concepts accessible and relevant across discipline. Yes. Thank you.